Okay, kids, I hope you're standing on a warm floor right now because your feet are going to get cold otherwise when I knock your socks off with this amazing lesson. All right, so we're looking at multiplying and dividing rational expressions. So section 6.2, a continuation along the non-permissible value train that we just got on. So multiplying, pretty simple stuff here. Like all fraction multiplication, you're just multiplying numerators together and denominators together. So if you have forgotten how to multiply basic fractions, just remember, if you had something like 2 over 3 times 4 over 5, well, you just multiply the 2 and the 4 together to get 8, and the 3 and the 5 together, and you get 15. So super simple. If I start changing any of this with variables, all of a sudden, almost nothing changes, to be honest. So you've got, like, so let's say x over x plus 1, we're multiplying it by 2x over, I don't know, x. You're still just multiplying x times 2x here, and you're just multiplying these together. The only thing that makes this a little tricky is now you've got variables, so sometimes your expressions are going to get a little more complicated, and we're also going to have to deal with non-permissible values, especially when we're trying to simplify. One big thing just to keep in mind is rational expressions. This divided by sign means there are hidden brackets around everything, so that's really important. One common mistake is to say, oh, there's an x up top and an x on the bottom, I can just cross them out. No, you absolutely cannot. You all can only cancel entire brackets with each other. So if this bracket and this bracket are exactly the same, they can't have any variation at all, they can cancel, but if they're not exactly the same, then you cannot cancel them, and you have to cancel the entire brackets. Sometimes you can do some stuff to modify it, sometimes you can factor something out or multiply something in to make it the same as something else, but you do have to do that step. So just as a quick little example, this seems like a barrage of x's. What can actually cancel out here? So in this case, what do we see? Do we see anything that is exactly the same? Now, this 4 and this 4, can they cancel? The answer is absolutely not, because this is 4 and this is 4 plus x, and they're totally, totally different, right? This is like saying here's the number 4, and here's the number saying 4 plus some other imaginary number. They're just not the same, unless x was 0. But it's not 0 all the time, so we can't just cancel. What we can do, of course, is we can see that 1 plus x is kind of related to x plus x squared, so we could always rewrite this as 1 plus x over 4 multiplied by, now, by the way, this is why I like to do dots instead of multiplying, because sometimes it looks like an x, so I'm going to do dots as much as possible. We can factor an x out of the bottom here to make this 1 plus x. Once we do that, now we can take this entire bracket and this entire bracket, and we can cancel them out, and we can simplify this to 4 plus x over 4 times x. And again, nothing can simplify here. You can't cross the x's out because this is plus x, and this is multiplied by x, so they're just not going to quite work. Okay, so non-permissible values, how does this fit into the whole thing? It's actually really simple. When you're multiplying, both expressions can never have a denominator of 0. So that's all there is to this. One thing to keep in mind is sometimes, like in the last example, you're going to start canceling things out. You got to get those non-permissible values before you start canceling. And just to reinforce the idea from last time, if I have something like 1 plus x over 1 plus x, can I always cross these out and say it's equal to 1? And the answer is, you can do it for every value of x, provided the value of x does not make you essentially dividing by 0. So in this case, the value of x that would make this problematic would be -1. So 1 plus x over 1 plus x is the same as just 1, provided x is never equal to -1. Okay, and that's a really important thing that's going to permeate through this whole unit. So please make sure you're clear on that one. We're always saying canceling works to effectively give us a 1, but you just have to make sure you're not actually ever divided by 0. That's why the non-permissible values exist. And of course, once you do some simplifying, you keep the non-permissible values of the original expression. So just like in that last example, if we just jump back here, we can see that a non-permissible value, and you would have found it right here, x cannot be equal to -1, you'll notice before we cross things out, that was a non-permissible value. By the way, this one also exists, x cannot be equal to 0. But you'll notice in the simplified version, this says x cannot be equal to 0 only. So what do? We cannot make these non-permissible values disappear after canceling, so those would be the two official non-permissible values. So just because a term cancels out doesn't mean its non-permissible value disappears. In fact, the whole point of this is you can't cancel if it was that non-permissible value. All right, so anyway, let's just do a little simplifying here. This is not too tricky. It's just a little bit of practice with crossing things out. Keep in mind, a term from the top of one fraction can cancel either with a term in the bottom of the same fraction or in the bottom of a different fraction. So just as long as something on top cancels with something on the bottom. And of course, we can see that 10 and 5, you can cross them out. Keep in mind, we're dividing top and bottom by 5. So we're going to write a 2 and a 1. It's not like the 5 magically disappears. It just turns into a 1 because we divided it by 5. And then we're going to divide x squared and x, where we're going to cross that out. So of course, the negative sign has nothing to cancel with. This x right here has nothing to cancel with. And we're left with negative 2x. And it's divided by, the only thing that's left over is this 3 right here. Now, when we did this, I didn't get the non-permissible values right away, which was actually my bad. I really should have. If you forget, it's not a big deal. Just don't go, well, this has no variables in the bottom, therefore it has no non-permissible values. That's wrong. This right here, this tells me x cannot be equal to 0. So when I simplify, I can say that this complicated business simplifies down to negative 2x over 3, but I also have to say x could not be 0. So provided x is not equal to 0, that is the simplification. Okay, just a few more here. You might want to take a sec, pause the video, and try them yourself. Okay, so what this will give us here is, looking at this, I can tell, so I'm going to get my non-permissible values right away. I can look at this and I can see that x squared minus 4. Now I could factor this into x plus 2 and x minus 2 because it's a difference of squares, or I might just have the wherewithal to just say plus or minus 2 would be bad. Over here, x cannot be equal to 1. So somewhere, you're going to want to make sure you just have that written down. I know I wrote it down there, but it's nice to put it all together. So in descending order, ascending order, getting bigger, negative 2, 1, and 2 would be my non-permissible values. Okay, so when it comes time to actually doing the simplifying here, we got to make sure everything's all hunky-dory. So we do always want to factor as much as we can before we start going nuts. Remember the idea, generally you're going to go non-permissible values first, then you're going to factor. Actually, I'm going to switch that around because often we want to factor to get our non-permissible values. It's easier to find them quite often, and then we'll do the canceling, okay? All right, so this becomes x plus 2, x minus 2. I'll use a dot for the multiplying here. I'm going to factor a 2 out of this guy, and then I'm going to leave this here. Okay, so what can cross out? I can see that this guy and this guy will cross out the entire brackets. I don't see anything else that's going to cross out. So what we're left with is 3 times 2, which is 6. And then on the bottom, x plus 2 is one term, and the other one is 1 minus x. Now you might be sitting there wondering, should I multiply those together? And the answer is probably not. Most of the reason why we're doing this is we actually like to have the factors on the bottom. When we go to graph this, which we're not really doing this year, but we're going to do in another grade 12, if you continue along, you're going to find that you're going to wind up getting things like asymptotes at these values, and it's just more handy to, I don't know what the graph looks like, maybe something like that. It's going to be more handy to leave it in factored form, is my point. So just leave it in factored form, that's good enough. Okay, here's C. So this looks like a lot of stuff that can factor. So let's go ahead and do it. So I'm just going to factor the top. This is going to be x plus 1 and x plus 4. The bottom looks like I can factor 2 out of it. So I'm just going to jot something down here. It's a little too much for me to carry in my brain. Okay, and this looks like it's going to be, that's a really ugly plus sign. This looks like it's going to be 2 Now, you could write x minus 2 squared because you can probably see it's a perfect square trinomial. I'm actually a big fan of writing it out 2 times because if I start crossing things out, I don't want to accidentally cross both of them out. So here we've got 4x minus 2, and then here we've got x plus 1, and then we've got x minus 1. Okay, so I did my factoring step first. Let's do non-permissible values. X cannot be equal to, and we can look at the bottom here. X cannot be equal to 2. X cannot be equal to 2. If a value repeats, then you just have to write it once. Negative 1 and positive 1. Okay, so negative 2. Whoops, sorry, my bad. Negative 1, 1, and 2 are the problems. Okay, so when it comes time to simplify, just to maybe show what I'm doing, I'll grab a different color. X minus 2 and x minus 2 are gone. So you can only get rid of one of them. You cannot cross this guy out as well. It's kind of a eye for an eye sort of thing here. So one term on top and one term on the bottom. X plus 1 and x plus 1 can disappear. Again, 1 for 1, and what you're left with here is you've got a 4 here and a 2 here. So dividing them both by 2 means we get a 2 and a 1. So what this simplifies down into is on top we have 2, x plus 4 is still remaining, and then we have x minus 2 and x minus 1. And again, I'm okay if you stop right there. You could multiply the 2 in on the numerator, but I'm not going to worry about it. Okay, dividing. So, as usual, what we can do is we can turn division into a multiplication problem by flipping the fraction after the division sign, right? So the old thing you learned in grade 8 or whenever you learned it to divide fractions, you just flip the second one. That's the same thing. You're always going to want to flip before you cancel. It's really important. The rules of canceling where, you know, something on top cancels with something on the bottom, that only works across a multiplication sign. It's possible to do canceling across the division sign, but they're like two things on the same side. Yeah, it's weird. Non-permissible values get a teeny bit trickier, and here's why. Let's say you had, well, I don't know, let me just think of something here. So let's say you had x over y, and you were going to divide it by a over b. So we can see that if y was 0, that would be really bad because we'd have x over 0, and that just doesn't exist. And we can see that if b was 0, that'd be really bad because we'd have a over 0, and that just doesn't exist. But here's another thing. If this entire guy here, this entire fraction was 0, that would be bad because then I'd be going x over y divided by 0. I would be doing a division by 0. So there's 3 things that can screw up when you're doing fraction division here. We can have the denominator of the first fraction be 0, we can have the denominator of the second fraction be 0, or we can have the entire second fraction be 0. And the way that you get the entire second fraction to be 0 is by having the numerator 0, right? 0 divided by anything is 0, well, other than 0, but 0 divided by 1 or 0 divided by 2 is always 0. So now you've got 3 things that can't be equal to 0. The only thing that's allowed to be equal to 0, that's okay. That's fine. There's no problem if x is equal to 0, because 0 divided by is not a problem. So keep in mind that when you're doing division, non-permissible values, you cannot have denominators be 0, and you cannot have the numerator of all the divided expressions. Only the first numerator, because that's not the actual division. Okay, so let's look at this example here and determine the non-permissible values of this expression. So the first thing I'm going to do is I'm going to look at this, and I'm going to I'm going to factor. Actually, that's the very first thing I'm going to do. So I'm going to go x over 4x divided by, and I'm going to factor this one out to x plus 1, x minus 1. Again, that's always going to help me find my NPVs a little easier. Okay, so where are the issues? I'm going to grab my highlighter. This guy here is an issue, this is an issue, and this is an issue. Okay, all of those things can never be equal to 0, and if they are, then that's bad. So this one has x cannot be equal to 0. this one says x cannot be equal to 3, but on top we have x cannot be equal to plus or minus 1. So when we're simplifying this, we're just going to have to make sure, you don't have to write NPV, by the way, it's fine just to write x cannot be equal to, but we're going to have to make sure that we've accounted for all of our non-permissible values first, and then we're going to flip and do all the simplifying stuff. Okay, so we're going to say -1 is bad, 0 is bad, 1 is bad, and 3 is bad. So we've got 4 non-permissible values. Okay, so once we've got that all taken care of, we can go ahead and we can write this. I'm going to do my flipping first. Okay, then I'm going to grab my blue and I'm going to just cross the things I can cross out. So we've got an x here and an x here. And an x minus 3, okay, well, nothing else cancels, so that's it. So this will simplify down to x minus 3 over 4 times x plus 1, x minus 1. And I'm happy with that answer. And provided that x is not equal to -1, 0, 1, or 3. Cool beans. Okay, a couple more examples for you. These ones just get a little bit bigger. All right, so the first thing we should do when we've got something like sort of overwhelming like this, keep in mind, these are all, contrived examples, right? Things are going to simplify and everything's going to get nice. So it looks horrendous, but things are nice to note, I promise. Let's do some factoring. So greatest common factor out of 4x and 10, I can actually take a 2 out of that. I can't do anything with this bottom guy. I'm going to do, I'm not going to skip too many steps. So I'm going to factor, holy smokes, what's 12? Okay, so 12x squared minus 60x plus 75. I think I can factor a 3 out of that before we get going. So just to maybe make my life a little easier, let's factor a 3 out. We're going to get 4x squared minus 20x plus 25. Now, I actually happen to be fortunate enough to notice this is the perfect square trinomial. So that's just a little bit of experience, but if you don't recognize it, you can still use the AC method or some other method. But I'll just cut right to the chase because this is not really a lesson on factoring so much as canceling. Okay, so we've got that, and on the bottom, now this is 2x squared minus 18, so I'm going to take a 2 out of that. I'm going to get x squared minus 9. Okay, so just because I don't want to write too many things too many times, I'm just going to cut right to the chase. I'm going to write this out. No, actually, I'm not. I'm going to leave the exponent up there because if I were doing this, I would do it that way. But this guy here, I'm going to write as plus 3, x minus 3, because it was a difference of squares, right? This was 2x squared minus 9, so that's 2x plus 3. And x minus 3. Okay, so what I'm going to do here is I'm now going to find my non-permissible values. Again, I'm going to highlight all the places where we had to be looking. You have to look at the denominators of everything and the numerator of the division guy, the divisor if you want to sound fancy. Okay, so here x cannot be equal to -3. Here, x cannot be equal to, I'll just combine these, plus or minus 3. And then here, x cannot be equal to, is that 5 over 2? So somewhere over here, I'm going to write, let's make just a little division. X cannot be equal to -3, 5 over 2, or positive 3. Those are all my non-permissibles. Okay, so now we go to the phase where we start flipping, canceling, and all that sort of stuff. So we're going to flip. This becomes x plus 3, x minus 3 here. And this one becomes this. So I know I said I quite often write out 2x minus 5 squared, like I would write the brackets twice. When I say that, I don't mean I would do it. I mean it's not a bad idea for you to do it. But personally, I would not do it. I would do this. I would say 2x minus 5. One of these crosses out with one of these, and I can even rewrite the exponent as a 1. X plus 3 and this x plus 3 are gone. I cannot simplify anything else, so the best I can do here is I'm going to put this all together. The 2 and the 2 gives me a 4, x minus 3 is there, and then what I have left is a 3 and a single 2x minus 5 on the bottom. That's it. Done. That's as far as it can go. Okay, and then we've got D. Oh, holy boy. Okay, so I'm going to just streamline my steps a little bit. So I'm going to factor and flip in the same step. Okay, so I'm going to change this. This guy flips, and this guy also flips. Everything behind a division sign flips. So I'm going to go x minus 2 on top, and I'm actually going to factor the 3 out of the bottom while I'm at it. And then I'm going to flip the third fraction, so it's going to be 4x squared on top, and 1 minus x on the bottom. Okay, so what do we do now? We get out our non-permissible highlighter, I guess. This, here, 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 and here. So all 5 of those places, I've got to go looking for non-permissible values. Okay. 0 is bad. -1 is bad. +1 is bad. This also says 0, and this one says 2. So putting that all together, x cannot be equal to -1, 0, 1 is bad, and so is 2. Okay, now we also do some crossy cross. Okay, so I'm going to cross things out. So x plus 1 and x plus 1 are gone. This x here and one of these x's are gone. The 2 here and the 4 here can cancel to be a 2 and a 1. We've got x minus 2 up top and 1 minus x on the bottom, but guess what? That's as far as that goes. So this simplifies down to, we've got a 2 times x minus 2. And then we've got, okay, I see it. I did the classic thing here. In all my crossing out, you gotta be real careful. What is left over? X minus 2 is left over. And see this little x in here? I almost missed that one. And this number 2, that's what's left over. So be real careful when you're doing this. 2x times x minus 2. So when you cross out the exponent, don't forget that single x is still there. Okay, so we've got a 3 and then we've got a 1 minus x. Is that as far as we can go? The answer is yippers. Alright, I feel like that should be it. Is that it? Good, okay. Well, not good, but anyway, I think that's enough for now. So there we go. There's some examples where you're crossing out. Fairly straightforward. As long as you've, passed your fraction unit of grade 8, you should be just fine. All right, thanks for watching. See you later.